Greetings and welcome, friends. Mr. Waddy here. We are continuing our adventures with systems of linear equations, and we're looking at solving systems using substitution, an excellent choice, if I might say so myself, when it comes to solving systems. Today we're going to take a look at a couple word problems. Technically, these word problems could be done using graphing or the elimination method that we'll talk about later, Monday even. But in the meantime, let's just figure this out. It says a drama club earns $1,040 from a production. Whoa! Crazy. A total of 64 adult tickets and 132 student tickets were sold. An adult ticket costs twice as much as a student ticket. So, right, they're giving us facts here, right? And I'm going to try to take those clues to assemble some equations through which I can solve my problem. It says, write a system of linear equation that represents this situation. And then notice the question, what is the price of each type of ticket? What is the price of each type of ticket? So first thing we do when doing word problems is we got to define our variables. And our variables are often going to be the question that they're asking. Price of each type. Each type of ticket. There we go. And so what are the each types? Well, X will be the number of adult tickets sold. Number of adult tickets sold. All right, there we go. And Y is the number of student tickets. Those were the two types, right? So what is the price? Oh, sorry. Oh, I lied. Guys, these aren't going to be number of. It said price. Uh-oh. Man, soap and price. Dear. Here we go. All right, watch this. I ran out of undos. I've got the craziest way to have to erase things. All right, so the price per adult ticket. Wow. That's better. All right, and Y will be the dollars per student ticket. There we go. I think my brain just went on autopilot there for a minute. All right, and then they gave us two separate facts. The first fact was about money. All right, they earned $1,040, so 1,040. The money they earned came from two things. Selling the adult tickets, which they sold 64 adult tickets, and if I take the number of adult tickets sold multiplied by the price per adult ticket, this would represent the money that came in from just the adult tickets. To that, I've got to add, what do you guys think I should add to that? What are your guys' thoughts? Oh, well, I'm still working with this first fact. So I said, all right, this fact up here. So they sold 132 student tickets. And if I multiply the number of student tickets sold by the price per student ticket, that term will represent the entire amount of money that came in from those student tickets sold. All right, so there's one equation. I've got two unknowns. If I'm going to solve this mystery, I need another clue, which will be related to this fact. It says an adult ticket costs twice as much as a student ticket. Does anyone have a guess as to how I could write an equation that represents that fact? Well, not this. Well, think about, let's see, an adult ticket costs, so adult ticket price is X. How does X relate? It's twice as much. Well, the 64 has to do with the number of adult tickets sold. This fact has just to do with their prices. So I'm just going to relate X and Y, which represent the prices. The 64 and the 132 I already used to calculate the amount of money that came in. But X, the cost of an adult ticket, is twice as much. So that means what operation? What's happening? Twice as much. What math do you translate that to? No, that was the total amount of money that came in. This is twice as much as a student ticket. Well, but the 64 was the number of adult tickets sold. The 132 was the number of student tickets sold. What number or variable represents the price of a student ticket? Well, I've got the 2 that's going to be multiplied by it. But what am I multiplying 2 by? What represented the cost of a student ticket that I've already written down? Oh, 132 was the number sold. Y is the price per student ticket. All right, so X is equal to 2Y. The price of an adult ticket is 2 times the price, all right, of a student ticket. All right, so writing those equations, that's the tough part. Assuming you already are going to be familiar with the solving of a system. All right, so now this is like gotten to a problem that I could have theoretically given us last night. Between my 2 equations, it's a system. I've got 2 equations and 2 unknowns, x's and y's. Which of my x's or y's should I solve for? Or would make it easier? Easiest. Thoughts? The x with nothing in front of it. All right, so when I solve, my step 1 is solve this for x. Oh, it's already solved for x, so I'm going to say x equals 2y. Step 2, I substitute. So I'm going to take this 2y and plug it in for the other equation's x. Right? If x is really equal to 2y, then that means I could swap them out at any time. All right, so I'm going to have 64 times x, which now I've replaced with 2y, plus 132. Ooh, I just wrote 2 twice. 132y equals 1040. These are looking like calculator numbers here. I'm thinking so. All right, so 64 times 2y is going to be 128y plus 132y. I'm just simplifying here, and I'm going to solve for the remaining variable, the y in this case. I've got some like terms. Let's get those like terms together. So 128 plus 132, 260. Well done. Well done. Oh, wrong color here. So 260 y's is equal to 1040. I've got to guess if this divides in evenly what that might be, but let's see if it is, what's it going to be? So divide both sides by 260. I'm going to get y equals, does that go in evenly? 4? I'm guessing 4. Yeah. Yeah, I'm thinking, yeah. Oh, yeah. So y equals 4. What does that mean in terms of our problem? Y equals 4. What was y measuring? What was our variable? You guys have it written down. What does y mean in terms of this problem? 4 is what? The number of students, the number of students in the play. 4 was the number of times a student forgot their lines. Well, what was 4 representing? What does 4 mean in like what was y? Well, y is 4, but in terms of the problem, what does y mean in terms of this word problem? We defined it with our variables. Dollars for what? Yes, that's the price per student ticket. So when I say y equals 4, I'm saying the price per student ticket is $4. All right. So let's see, we solved half of the problem. And now if y is truly equal to 4, that means I can substitute it at any time. That's what we'll do for step 3. So I'm going to have x equals 2 times 4. And I got x equals 8. And what does x represent in this problem? That's what I said originally. It wasn't the number of adult tickets, it was the what of adult tickets. Yeah, the price per adult ticket. So so then I'd answer the question. Actually, let me write. That's right. I write the A for VESA, variable equation, solve, and answer. So adult tickets cost $8. Student. I just wrote end. I was gonna write student. There we go. Tickets are $4. All right. So when you write your answer, you're literally just saying 8 equals x. What was x equal to? And you check the, where's my scroller here? There it is. And you check what your variable definition was. Oh, price per adult ticket. So $8 per adult ticket. Like it almost writes itself. It almost writes itself. Right? And so we were able to solve this system using substitution. Now, graphing, we could have solved this. We probably would have gotten the right answer, right? Like this is a friendly enough solution that graphing would have worked just fine. But if this was like $8.32, graphing would have been a pain. All right, graphing would have been a real pain. All right, here's another fact. Here's question 8, follow-up. This is from the monitoring progress. It says there are a total of 64 students. Oh, no, this isn't a follow-up question. I just saw, man, my brain. I just see like the word student. I'm like, oh, I definitely know where this problem is going. I do not. It's about the drama club, though. So that's where I was thinking. There are a total of 64 students in drama club and a yearbook club. So that sounds like the total of both. Yeah. The drama club has 10 more students than the yearbook club. Write a system of equations that represents this situation. How many in each club? So let's define our variables. What should our variables be? What should x represent? How many in drama club? X equals, and it's a number, right? How many? It's not like, right, the price per student this time. It's x equals the number of students in drama club.
Okay, when you look at it without reading.
Yeah, well, that's why we're going to solve this with some clues. Yeah, there might be some ways you could kind of figure out the solution without solving by substitution, especially because these are going to be friendlier numbers. Basically, if I was solving this just like if substitution didn't exist and I was just like trying to guess it, I would say, all right, there's 2 clubs. I would divide 64 by 2, I'd get 32. And then if one of them is 10 more than the other, I can't just add 10 to 32. I would add 5 to 32 and get 37 for one. And 5 less from 32 is going to be 27 for the other. And that's probably the answer. But we're going to solve it using a system, and this solving by substitution will work when the numbers are so unfriendly that I would never be able to like just have a little trick to figure it out. All right. So let's see. Y is going to be the number of students in yearbook club. Yearbach Club. There we go. All right, so let's write some equations. First equation, total of 64 students. Here, let's see, I'll even write my equations in 2 different colors. Total of 64 students. Maybe I'll use green and red, tell you what. Total of 64 students in drama club and yearbook club. How could I translate that into a math fact using my new variables? What do you guys think? Could you write an equation that represents that? Total makes me think I'm adding things. If the total is 64, then the sum of those 2 things is going to equal 64. What 2 things add together to be 64? Well, hey, you're giving us the answer based off of what I already have labeled, or numbers or facts from the problem.
32.
Right, but I need to write it based off of facts that they've given me. So they said the total number of students in both clubs is 64. I have variables that represent the number of students in both clubs. I'm going to get there. I'm going to get there. I think I'm going to get where you're going. But my first fact, I would say the total number of students in drama club plus the number of students in yearbook would equal the total number of students. So x plus y equals that. Let's write the second equation. It says the drama club has 10 more students than yearbook club. All right. So what's an equation I could write that? The drama club. All right, so that is x. So x has 10 more. So I'm writing x equals, I'll write it over here actually. X equals 10 more. That means what mathematically? 10 more. How do I represent that? Am I dividing by 10? Am I multiplying by 10? What does 10 more mean if I'm writing an equation? If it said 10 times, I'm adding 10, right? 10 more than something, so I'm adding 10 to something, and it's 10 more students than the yearbook club. What represents the yearbook club? The number of students in yearbook club is y. Aha. So here's my 2 equations. All right, so translating those facts to equations using our variables, that's going to be the tricky step, no doubt, no doubt. So let's solve that system. Step 1, solve one of those equations for one of its variables. Actually, look at this. This one's a good choice, this one's a good choice, this one's a good choice, this one's a good choice. They're all great choices. Which is the best choice?
No.
The bottom one for which? For x. And why do you like that? Because it's already solved for x, right? Why create more work for ourselves? This one is already solved for x. But all of them had positive or negative ones as their coefficients, right? And one coefficient, yeah, they all had positives in this case. But yeah, we might as well solve for the one that's already solved. So let's see, if x equals y plus 10, then that means I could substitute this in for the other equations y and not break any laws, right? I can just swap those 2 things. They're equal, indistinguishable from one another almost. So let's see, so x plus, and instead of y, nope, super elite. What did I do, guys? What did I do wrong? Who sees my mistake? I pointed it at the y. This is not equal to y, it's equal to x. Oh dear.
No, I did point it right. You pointed it at the y and I erased it.
Aha, good save.
No, I actually had it.
Right, yeah, you guys are here to help me. I'm glad. So I do that substitution. So I'll have y plus 10, all right, is now in place of x. I don't technically need the parentheses because this x wasn't being multiplied by something, you know, it wasn't. So I don't need the parentheses there. Plus y equals 64. So now let's solve. Combine like terms. All those terms. Here we go. So I'm going to have 2e 2y plus 10 equals 64. Yeah, you got the algebra down now, right? And I'll have, this is our last example for today. 2y equals 54. Divide both sides by 2. Let's see if our answer is right. The one that we guessed earlier. Y equals, let's see, half of 50 is 25. Half of 4 is 2. 25 plus 2 is 27. That was one of our answers. And now how could I find the value of x? If y equals 27, then plug it in for this guy right here. Whoop, 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 whoop. And that's going to be step 3. So I'll have x equals y, which is 27, plus 10, and I get x equals 37. So what does 37 and 27 mean in terms of this problem?
37.
So drama has 37 students, and yearbook has 27. There we go. Bam! I love it. I love it. All right, well, thanks for watching, mis amigos de el internet.